Hello, I am Developer and I'm joined today by Mark Woods, Chief Technical Advisor, EMEA at Splunk, and today we're going to be going over observability. This is going to be one of 2 episodes on observability and giving an overview on that. Over to you, Mark.
Hey, well, it's great to be here today. I suppose my background, I'm really a fiddler and technologist. I suppose I've probably spent a little bit too long in the business line to really still call myself an engineer. The last time I got my fingers dirty was a long time ago. But I do spend a lot of time, I think, at the moment with some of those exec teams, mostly focusing on how data-centric approaches work and really where the beneficial change is.
Nice. So you don't miss getting your hands dirty with code?
I do really. If you could see the proliferation of bits and pieces on the shelves behind me, I mostly break things at the moment. But yeah, I've had the real great opportunities in the past to build companies, including starting my own company, where I think I realized that my time as an actual developer was over when one of my core product teams begged me nicely in the background to stop messing up with their code base.
Yes, I understand entirely when your access is suddenly taken away. Excellent. Well, if you're happy to dive in, I've got some questions on Splunk observability. I suppose the biggest question for me is, in terms of when you're designing these tools, do you think it's the tools themselves that tend to drive the innovation for developers, or is it vice versa? Is this a chicken and egg thing? Do we give developers better tooling and enable them more freedom and expression for innovation? Or do developers crusade forward with unwieldy innovation and basically we have to make tools to catch up and clean up the mess and kind of stay one step behind them and enable more innovation? How do you see it?
So I think that invention itself, the new ideas, the way we drive things forward, always come from the developers, always come from those people that are creating things that are new, not the tools themselves. But if we sort of define innovation as how you apply things, get them to work a bit better, then really it depends on the sort of maturity. And I think importantly, the organizational speed of the business itself. And what I mean by that is if you have a sort of super mature business, then actually the tools are probably going to be getting in the way of innovation. And that's simply just because of the proliferation we normally have of those and those sort of natural silos. But actually, if you have that sort of organization that has quite quick execution speed, i.e. making decisions really quickly about where they prioritize resources, then lots of the time those tools themselves can help to focus and drive some of that innovation and actually reduce the toil down for developers teams by making sure that you're not racing off down trying to get to a solution that hasn't probably been properly defined, or you don't really understand the sort of now state to work forward from.
Yeah, so do you think that it's possible to work in parallel between the tooling and the innovation and each drives each other, enabling better tooling and better innovation at the same time?
Yeah, I think there always has to be a recognition that whilst you can use new tools or specific tools to what you're doing, unless that's all able to come together to actually give you an overall picture, then you're always going to be in the way of innovation rather than stimulating it. And I think as a developer, you've probably seen that before with tool chains. So with actual ways in which we integrate and deploy, that there were lots of areas where you're begging out for tools to make it quicker, to automate it quicker. And we're probably at the stage now where there's probably too many, and different teams use different tools, which doesn't enable innovation at a business level. It may mean that your overall pace and your overall agility is quicker within the team, but across teams that actually gets in the way of that innovation being deployed.
Yeah, absolutely. I know from personal experience, the developer in me wants to build new functionality and move at a speed, and that gets frustrating with tools. And then when tools catch up and take over, then it's suddenly the tool chain's problem that I can't develop as quick because I have to learn all this new tooling that my development needs demanded.
And if you find that a tool is getting in the way, then it's time to either change the way in which you're using it. And lots of the time, it's not necessarily the tooling itself, but the way in which you're interacting with it. And the simple idea of this is the sort of guardrails we put on things like logging. If people consistently share and it's shared as wide as possible, then actually it can be a real useful resource for innovation. But if it's done in different ways, it just becomes an extra toil, because somebody's going to ask how you can interpret it. Somebody's going to start saying, well, actually, can we start to now move this? And the hard thing a lot of the time with tooling, and particularly sort of my passion, which how data tells us about a thing, is that actually if you don't invest in that upfront, you can't really use it retrospectively. The amount of retrospectives I've been to where it's, oh, well, we'll go and investigate now, means that actually at the time you've kind of lost the opportunity to have it in place. And what you're doing is putting an extra burden on those development teams to go back and look at it. We all hate it as we're developing new things, new innovations, to sort of take a second's pause to say, am I capturing the data in the right way? Am I potentially allowing the operational teams to understand what I'm doing a bit better? But I think it's this closed loop, and we've all seen them from the sort of software development life cycles, where you've got this lovely closed loop where once it's been deployed, we get that feedback. But I think that's the key for tools that drive innovation. It's the ones that can give us the context and the ones that create the minimum amount of toil to make sure that when we get to that point of understanding the overall system, we can get there quickly.
Excellent. I'm just thinking, you were saying that the context and the kind of the retrospective, but in terms of designing these tools, do you find that it's the developers that are feeding information to the tools and giving them the context? Or is it the tool's job to infer from the system automatically what's needed? Or again, is it a collaborative process between the developer and the tool to increase the information sharing and knowledge sharing?
So I think it always has to be that relationship between the tool and the technology and the developer itself, and indeed between the business. Because if we're talking about those higher order things, those things that really drive value, without the context, then it's useful as a tactical tool to make maybe operations a bit faster, but it's never going to be able to give you that sort of source of truth. So you can actually start to understand, is this actually affecting the end user? A particular outage, a particular thing, is that actually starting to make people angry? Is it something that has that sort of high blast radius where, yes, it may only be a few people it affects, but those are such premium customers, or they're geared up in such a way that they're going to create a lot of problem for the business? But I suppose at a developer level, then you can infer some things automatically. And I think when we talk about observability from a technical definition, that is pretty much about being able to infer what the internal state is of some of these systems from what goes in and what comes out. And that should be automatic. It shouldn't require you to break down some of those containers. It shouldn't require you to break down what you can't, which is a serverless function. You actually should be able to infer what the state is going through and actually be able to provide a higher level context that allows you to understand when there are intermittent errors, allows you to understand when actually some of the criteria, some of those metrics that you may have defined, or the service level objectives, aren't being met by the particular change you're about to push.
Nice. So I suppose for a developer, they can set the tool up with the correct knowledge. The tool can infer as much as it can automatically, but the developer dream would be for a tool to tell me something that I didn't know. So a kind of unknown unknowns, and prevent me from kind of making future errors that I just haven't considered, where the tool's knowledge could be far greater than what I've given it. And also, could infer more than I've given it to kind of pre-warn me about those issues.
So I think it can, but I think we have to be practical about what's achievable. I think we're talking a bit about automation there. And really for me, automation is about the knowns. So it's, for me, the same data, the same consistently broadly captured operational data. So that's as you're making the change, as those systems are operating. But for the knowns, for those areas that you know may be a problem, or that you're actually trying to change, so I'm trying to drive a change in the overall performance, goes faster, doesn't use as much resource. And when it doesn't work, well, we've got a simple automation there. We can do a rollback. The other automations in there is to flag certain ones, those areas, to say, actually, this seems to have a lot of dependencies. So actually, I can start to flag and then run some of the playbooks on top. When we go to sort of unknown knowns, then that really is more about resilience than robustness. What I mean by that is that we can't design those out, or rather, even if we couldn't, we probably shouldn't, because the toil and the effort isn't worth it for something that may be intermittent, something that may only happen once or never. And it's in those spaces where actually understanding the alerts and, ideally a recommendation or at least a grouping of what that is means that as a developer, if I'm actually moving through to, build it and operate it, that I know when I've got to actually get involved and when I can just put it onto the backlog and the I'll get to that at some point error list.
Yeah, never-ending backlog.
But I suppose you were talking a bit about unknown unknowns.
Yeah.
And for that, it is utopia if you're talking about actually saying there will be something that can tell me those immediately. What it is about is actually that same data, the same data I'm capturing, those logs, the key metrics, so what is important to the business, and then importantly, how those are linked together. So traces if you're in a cloud-based environment, transactions if you're in a more traditional environment, help you to have that context so that when a change happens or when that chance that you didn't look at happens, you've got a faster response. So when you're called in, if you've got a DevOps team or if you've got a site reliability team who start panicking with their hair on fire because something's happened that they haven't seen before, you're able to actually use the same context you're using for the knowns, the same way of actually understanding some of the context with, how many alerts have I seen, how many recommendations have I seen?
Yeah.
And then importantly, once you've done that and the fire is out, you can start that retrospective immediately because you can start to learn for the future. And that when it breaks, that you can get there quickly to a resolution and almost build back stronger is about thinking about resilience. And that resilience is about visibility and observability, if we define it like that.
Yeah, that's great. With the shift to cloud and like you mentioned serverless, how would you go about designing tools for dynamic systems nowadays, where the sort of scalability is potentially infinite versus again, going back to the sort of known issues of more static, traditional infrastructure?
I think the first point is to understand that whilst some of the underlying technology and the operating model is fundamentally different, actually the approach shouldn't have changed. The difference for me is that the two fundamentals that have changed is that actually it's difficult and often impossible to define where the boundaries of a service or a product are. And with that flexible nature of deployments, the links, the dependencies, that's compounded by the ability to not just massively scale, but also massively shrink when required. And if you think about some of those traditional approaches, when you had static infrastructure that actually has some of those underlying benefits of actually needing phasing to scale and generally only in one direction, that's allowed traditional approaches to monitoring, to understanding the system to be good enough, to be able to paper over the cracks, to actually work within separate teams. So the first fundamental with those is that you need to make sure that you're not just papering over the cracks, that you have a good broad understanding and that actually you're able to share between teams, because defining this as team A and team B doesn't work anymore, especially as you start to scale and you get 25, 50 different product teams, because they're going to have interlinked and intermittent dependencies. But I suppose the second fundamental is it's different in the way that those systems and the pathways themselves work. And that's because with the systems themselves, they won't necessarily exist forever. In fact, the majority of them, if we're driving towards those fundamentals of trying to get the best cost efficiency and the best overall scale, they actually won't exist for a long period of time. And then with potential pathways being myriad, and they're errors that don't necessarily repeat, and you can't necessarily repeat them in the same way, it means that you need to capture that transaction, that trace, and that data when it's happening. And it means that in a system where you do get intermittent errors, in fact, they're rife. Every time I've deployed serverless systems, you kind of accept the fact that you're going to get some of those intermittent problems. But you need to understand the potential impact. Whilst extremely difficult, you can't do that sort of deep dive root cause in retrospect. So what you often end up with, without a proper observability stance, a proper way of capturing that at full fidelity at the time it's happening, you kind of get the meh with a shrug, and you kind of hope it doesn't repeat again. That works fine if you're just experimenting. It works fine if you have a niche deployment and a great team. But actually, as you scale, and we're talking about scaling being potentially infinite at this point, the compound effect of that has a real point of saying, is this genuinely going to impact my end users, and when? And without being able to do that in that real-time environment, pretty much impossible to start going to do that in retrospect. And I suppose the way in which we start to look at those tooling is to say, well, actually, part of it is getting the data in, and that's fundamentally different. It's as near to real-time as possible, and it needs to be comprehensive, because it's hard if you're just sampling for that. I can tell you overall, how did a system perform? But I can't tell you where was that intermittent failure. And especially as that links to an endpoint impact, you can't go back in time to do that.
So it almost seems like the cost of infinite scaling is just a general understanding of what's the maximum kind of tolerance I have for just accepting that some things are going to be rife with the errors. But with infinite scalability, I'm kind of building more for resilience versus the complete knowns and maybe the drawbacks that brings, because I get greater innovation, but I also get the cost associated with that.
Yeah, and so what I think within, especially as you're starting to go to hyperscaling some of these particular services, especially as you get to the point of saying, well, actually, in the ideal world, I want my service to be able to scale to meet that end user requirement without compounding those intermittent failures, is that you need to complement both approaches. So you need to make sure you have a broad understanding, and that means bringing together data from both the business, the services and applications themselves, and the underlying infrastructure. But it means that because your underlying operating model has changed, that the way in which you capture that data and flow it into the system also has to complement that. But in the ideal world, yes, you would have 100% real-time, high-fidelity observability across everything you're doing. Practically, you need the capability to be able to do that with that wide context. To call it an overused term, it's almost a T-shape. But this time, rather than being the T-shaped developer, what you're actually looking for is that T-shaped visibility, broad understanding of the services that I'm delivering, and the ability to dive down deep into those areas that have the biggest blast radius impact and those things that I'm changing.
That's great. Well, thank you for that, Mark. That was really, really informative. Unless there's anything else you wanted to go over, I think that brings it to a nice conclusion.
Yeah, I'd say that the key thing for me as we move towards some of these areas is actually understanding the extended operating environment, and lots of those mean using SaaS tools. The strange thing for me all the time is that when we talk about certain tooling sets, especially when it comes into monitoring, that somehow we start to divert ourselves towards deployed software. I'll take the software and I'll put it onto a particular device, or the meh scenario of, well, it's good enough to actually just pull the logs into one place. So the one reason that I work a lot with customers of saying, actually, this abstraction, this way of taking your visibility and the way you observe as separated from the actual system itself, and then looking and saying, well, why would you now try and deploy that back onto the same system? Becomes a self-licking lollipop a lot of the time, but actually it's one of those areas that it makes sense to keep that as a service. It's one of those areas, I think, for developers that we should be pushing hard on, because no one in a business would even consider putting a CRM system necessarily on-prem, or an enterprise process system on-prem. And yet sometimes when we talk about our tooling, that seems to be sometimes the default.
Yup, and this is where a Splunk Observability Cloud could help with that.
I think having that flexibility to be able to do the same thing. So Splunk Observability Cloud means it can be run as a service. It also means it can complement some of those existing infrastructure side of things still as a service. And in those really rare cases, when you do actually need to deploy something onto existing tin, then it can flex and do that as well. So the first thing you need to think of to try and make it easy is to try and consolidate as much as possible into one place. At Splunk, we have all this within one suite called the Splunk Observability Cloud, which is now available in EMEA. But it's actually what you do to bring together all of that that makes the difference. It's bringing together both a best-in-class streaming architecture and a way that you can scale to meet those needs as data's fed in. But it's also a way to bring together some conventions. Things like open telemetry, which you can bring together with traditional deployments to make sure you understand the context for your business, and you can automatically start to generate deeper insights. But you also need to leave it open enough to make sure it's relevant to your particular environment and any environment that you have to change to in the future. It's really important when you're making an overall system observable that it's also relevant to the business context, meaning you're actually looking for answers of not just what, but why and how that you can start to answer those business questions. And importantly for developers, you can understand more of the context in what you're trying to improve and rectify.
Absolutely. I always find that the good questions start with the why, and where am I trying to get to? It kind of sets the course. It's all great having lots of data, but why is it meaningful and what can I do with it?
That context and where it touches also allows you to link that to the why that you're getting from the product manager, product owner, or the business itself. Because actually you can look to see how real is this, how significant is it, and actually sometimes a different approach, that different innovative approach, because it's not just about, as a developer, saying, okay, this is a new way to send my logs, this is a new way to send telemetry, but actually a way to close that loop so that from the business, from the product, you're able to understand those areas to say, actually, if I'm being asked to make this stickier as a product, well, we can look at, how was a particular ad effective to actually understand why a front-end design may drive purchases. Or, when we say we've got really angry users because of an outage, to understand if that's one, intermittent fault driving that, or if it's something consistent that we can actually design out of the system itself.
That's brilliant. Well, thank you very much, Mark.
Thank you so much for your time. Really appreciate it.